what we know is what stem cells can do in the lab.
Yeah.
You know, there's been lots of projects looking at, you know, the growth factors and the cytokines and things that stem cell releases, and the potential effects of those, what happens in the test tube. So we've got great data on that. We've also got very good data on tissue generation. So stem cells can form cartilage, can form bone. We can do all this, you know, in the lab. What we're lacking is what happens when we put that in an animal.
Yeah.
And what effects are we seeing? These same effects. So I think what we should take a big take-home message of all these different what are called in vivo studies, so within the animal or person, is that stem cells are safe.
Yeah.
So there is, I haven't found one study that says that, you know, they injected stem cells and there was a problem. You know, the side effects there's no side effects. So they are very safe, and that is for allogenic cells as well as autologous cells. So that is one good thing. But there are lots of studies that look at the effects, but it's small groups of animals, and some of these studies are not particularly well designed in that you haven't got controls and you haven't got the numbers involved. So it becomes difficult when you start interpreting that, you know, is that solid sort of evidence? But that is the case with any new technology. We've got, you know, as the research grows, you know, studies are better designed. Once we learn more, we need to know what else we need to look at, and these things happen.
Yeah.
In the patient, though, it is difficult. It's very different lab work and trials in there. That there's a lot of difficulties where we look at clinical outcomes.
So I did a workup on a dog today, and it had mild elbow dysplasia, bicep tenosynovitis, supraspinatus tendinopathy in both shoulders. It had trigger points in both latissimus dorsi. It had trigger points down its back. It had sensitivity down the dorsal spinal processes. It had changes within the intervertebral disc in most of the lumbar vertebrae. It had mild hip dysplasia. It had iliopsoas fibrosis, and it looked like it might have a little bit of an upset stifle. And then, you know, if somebody was to put stem cells just in the stifle,
that is, you know, stem cell therapy is a targeted treatment.
Yeah.
So you're putting these stem cells into an area where it's going to project manage the healing, hopefully produce new tissues, new cartilage, repair tendons. But if you've got a hip and a knee problem, you're just putting them in the knee, you're unlikely to get, you know, any benefit from the hip. So that's where diagnostics is very important. A drug, you know, a pain-killing drug, you take that orally, it goes in the bloodstream, goes throughout the body, and it will treat pain and inflammation wherever it is. With stem cells, yes, you can give them intravenously, but, you know, if it's a joint pathology, you want to put them directly into the joint. Then you can guarantee the highest numbers, but, you know, you've got to also treat all the surrounding muscles, tendons, because we know that they are very commonly affected. Yeah. And I think the classic example is elbows. Yeah. We see a lot of cases of elbow dysplasia, and I would say pretty much 90% of them have concurrent shoulder tendinopathies. And I think it's a big reason why dogs with elbow dysplasia will have a very stable pattern of, you know, they're doing well on a non-steroidal and exercise management, weight management, but then they suddenly deteriorate. And I think that's not necessarily always, you know, we've got a flare of arthritis. I think that's when the shoulder tendons